Today's lesson is lesson 2-2. In 2-1 we were able to find conditional statements, the if-then statements, and now we are going to use those basically in a variety of different ways. Hopefully by the end of this lesson you can say, I can find the converse of a conditional statement, so we're going to learn what converse means, and I can understand how definitions create if and only if statements. So first off, we basically need to talk about what a definition is. I know we all understand the concept of it. Basically, again, if we are going to think about a word and we want to understand it more, we figure out that we can look in the dictionary to find the definition of it. But for our book here, a definition is an exact explanation of the meaning of a mathematical word or phrase. So specifically for our book, we are going to basically say it's a mathematical word. And these definitions, as we go through, we're basically going to relate them. So again, it's the exact explanation, and we're going to find out why here in just a second. So for example, if we take a definition that we pretty much know already, a square is a two-dimensional figure with four equal straight sides and four right angles. So again, four right angles we'll learn later on is our definition of a rectangle, but a square is specifically a rectangle with straight equal sides. Okay? And what we can say, we could create kind of a conditional statement from that, which says if a shape is a square, well then it's a two-dimensional figure with four equal straight sides and four right angles. So we're taking our definition, which we already know, and we're creating that conditional statement of an if-then situation. Now definitions, we're going to find out here in a little bit, have something extra with them. Okay? But just again, this is an example, so just if you want to write this down you can, but just hopefully to kind of understand that, again, we can break it down like this. So again, that conditional statements, that initial easy form to write it in is A, or if A, then B is this arrow. That's what that means. We learned last lesson. The converse, though, of our conditional statement is found by interchanging the hypothesis, A, and the conclusion, B, of a conditional statement. So we have our conditional statement here. So basically, again, we are going to basically interchange, or we're going to flip them to create the form B, if B, then A. And so what the converse of our A, then B statement is B, then A. And now we'll use this. So I would say, again, just write this down, and then I'll be able to give you an example here on the next slide. So let's go back to our original. A square is a two-dimensional figure with four equal straight sides and four right angles. We all hopefully will agree with that. Our previous statement, which I stated, was if a shape is a square, well then it is a two-dimensional figure with four equal straight sides and four right angles. Now I'm just going to kind of move that one off to the side, and let's write the conditional statement of that. So again, the converse of that, which is, again, if our original statement, our hypothesis is if a shape is a square, then our conclusion is it's a two-dimensional figure, okay, with four equal straight sides and four right angles. Now I'm going to take those and I'm going to flip them. So if this is my A, and then the two-dimensional straight sides right angles is my B, I would flip it then and basically say if a shape is a two-dimensional figure with four equal straight sides and four right angles, well then the shape is a square. So as you can see, I've taken the shape as a square initially, if a shape is a square, my hypothesis, and moved it down to my conclusion down here, then the shape is a square. Which again, is this converse true? If a shape is a two-dimensional figure with four equal straight sides and four right angles, then the shape is a square? Well, it is actually. And so what we can conclude from this is basically all definitions. So if we say a square is all of this stuff, then we should be able to conclude this, that if a shape is a square, then it has these properties. But also, if a shape has all these properties, well, then it's a square. Definitions have their initial conditional statements true, and also their converse statements are also true. We know that, so that's what changes with definitions, is the flip of it is true. So write the converse of the following statement. If it is raining, then you will need an umbrella. So if I basically required you to take this time right now. I would like you to pause the video, and just for your own good, just pause it and take a guess. So again, think about it as what is my hypothesis? What is my conclusion? What would I then flip to basically, again, keep the if the same, keep the then where it is, but change those other things around. So if you could pause it for me and try it. Hopefully now that you've tried it, okay, we take our hypothesis, which is if it is raining, then you'll need an umbrella is my conclusion. So if you need an umbrella, then it is raining. Hopefully you have that written down there. Okay, so if the homework's going to ask you for the converse, that's what you would actually write this sentence. Now, the first statement up here, if it is raining, then you will need an umbrella. We're just going to assume that to be true. Okay. Now you could sit there and say, well, what if I have a hat, or what if I have this? And we can play the if statements all the time. But again, just for our assumption right now is we're going to say that if it is raining, then you actually will need an umbrella. Now the question is the converse of it. Is if you need an umbrella, if you need an umbrella, then it is raining. Is that always true? Could you come up with an example of basically a time in which you would need an umbrella, but it's not raining? Now, you could sit here and say, well, if it's raining, I don't always need an umbrella. But again, we are just going to assume for right now that this is true, but does that make this true? If it does, then that means that we could make a definition out of this. Basically saying, you will need an umbrella when it is raining. Or, if it's raining, then you'll need an umbrella. Both of those statements would be true, and so you'd be able to create that definition. But hopefully you were able to say that the converse of this statement is actually false. And the fact that if you need an umbrella, then it is raining, well, what if it's sunny? Some people outside will use an umbrella. If it's just sunny, it doesn't necessarily need to be raining. So we can't necessarily create a definition off of this, but just remember again, definitions are special in the fact that both of these statements would be true in that case. Now again, so if we have our hypothesis, if A, then B, and if B, then A, okay, as we said before, for definitions, the converse is always true. Our previous statement with the raining wasn't, so it wasn't a definition. But for definitions, this is always true. In this situation, we create what's a new phrase, which is called if and only if. Or if you want to simplify it, and this is actually common, it's not a misprint, but it's actually IFF you would write. So if I take that and slide that up, so if A, then B, and if B, then A, we create our whole new symbol, which is, then we can conclude basically this if and only if statement. This arrow right here, this double-sided arrow, means if and only if. So A, if and only if B. So I need an umbrella if and only if it is raining. We could also flip that to say, it is raining if and only if I need an umbrella. Now again, as we stated before, that situation, that example, doesn't always necessarily hold true. But for our definitions of if it's a square, then it's a two-dimensional figure with right angles and 4 equal sides, we can also then flip it in the same sense. So again, this double arrow means if and only if, or IFF, as you can shorten it. Now for the final piece here, all right, I'd like you to take the statement, if you like geometry, then you like math. What is the conclusion of this statement? So again, think about it in terms of that arrow situation. Where is my A in here? Where is my B? Which one is my conclusion? I want you to write that down. Write the converse of the statement. So again, as long as you are looking at the A implies B situation up here, remember, look for your ifs and thens. That will help you out. Write the converse of it, so flip it. Does that necessarily mean that is the converse true? We don't know. Okay, I want you to be able to tell me. Does it have the same meaning as the original statement? Okay, meaning does your original converse statement mean the same thing as what it is up here? Is it a definition? And I would like you to have these 4 things tomorrow for me when we go over this this lesson in class, and then we'll be able to do some extra problems to help you with the homework. So again, thanks for listening. And bring these the notes and these 4 answers to me to class next time. Thanks. Bye.